Could we really colonize Mars? For decades, the Red Planet has fascinated scientists, dreamers, and space enthusiasts alike. What was once the domain of science fiction is now a very real discussion among engineers, researchers, and entrepreneurs. With SpaceX planning manned missions, NASA investing in Mars exploration, private space companies gaining momentum, the idea of living on Mars is becoming more tangible. But just how realistic is it? And what would it actually take to not only visit Mars, but stay there? Let's start with the obstacles, and there are many. First, there's the Martian atmosphere. It's 100 times thinner than Earth's and composed mostly of carbon dioxide. It means no oxygen to breathe and worse, virtually no protection from harmful cosmic rays and solar radiation. Mars lacks the kind of ozone layer that shields us here on Earth. So any long-term human presence would require specialized suits or heavily shielded habitats. And then there's the temperature. While parts of Mars can reach a comfortable 80 degrees Fahrenheit during the day, at night, or in the polar regions, temperatures plummet to an unforgiving -200 degrees Fahrenheit. Designing habitats that can maintain a stable, livable temperature under such conditions would be a massive technical feat. Keeping them powered around the clock would be an ongoing challenge. Water is another big issue. While satellites and rovers have discovered evidence of frozen water beneath the surface and in the polar ice caps, accessing it is no easy task. Drilling through rock-hard ice in low temperatures and low gravity, while ensuring energy efficiency and equipment. Durability is something we're still learning to do, and even if we do access it, converting that water into clean, drinkable form and using it for farming or fuel production adds another layer of complexity. So why not change the entire planet? Enter terraforming, the process of transforming a hostile environment into one that can support human life. It sounds wild, but scientists have put forward several theories. One idea is to introduce greenhouse gases, like carbon dioxide and methane, into the atmosphere to warm the planet. This could thicken the atmosphere, trap more heat, and eventually allow for liquid water to exist on the surface. Some proposals even suggest targeting asteroid impacts to trigger this process and release gases trapped in the Martian soil. Another theory involves melting the polar ice caps, as doing so could release massive amounts of water vapor, a powerful greenhouse gas in its own right, and even create rivers, lakes, or shallow seas over time. However, none of this would matter without protection from the sun's radiation. Mars doesn't have a magnetic field like Earth's, which means its thin atmosphere is constantly being stripped away by solar wind. Scientists have proposed creating an artificial magnetic shield, a magnetic dipole, positioned between Mars and the sun to deflect solar radiation. It's a bold idea, but if successful, it could give Mars a fighting chance at long-term habitability. Of course, none of this matters without the right technology. Colonizing Mars requires more than just big rockets. It demands sustainable life support systems that can function independently of Earth. Closed-loop systems will be essential. These are technologies designed to recycle air, water, and waste within a habitat. Imagine breathing in oxygen, exhaling carbon dioxide, and having that CO captured by algae or chemical scrubbers, which then convert it back to oxygen. Every drop of water would need to be filtered and reused. Every bit of waste would be treated and reintegrated into the system. It's like building a miniature Earth, where nothing can go to waste, and we'll need to build a lot. Transporting construction materials from Earth would be expensive and impractical. That's where 3D printing comes in, using Martian soil or regolith as a raw material. 3D printers could manufacture everything from shelters and tools to roads and infrastructure. Robots and automated systems could build entire colonies before the first human even arrives. This approach saves time, money, and lives. In addition, Mars doesn't get as much sunlight as Earth, and dust storms can last for weeks. Space-based solar power. Satellites that collect solar energy and beam it down to the surface could provide a reliable and continuous power source, ensuring life support systems and research operations stay active. But why go through all this effort? The potential rewards are immense. Scientifically, Mars is a treasure trove. By studying its surface, geology, and potential traces of past microbial life, we could answer some of humanity's biggest questions. Are we alone in the universe? How do planets evolve? Could Earth face a similar fate one day? On a more practical level, Mars might hold resources we can use. Frozen water for drinking and fuel, metals for building, even rare elements that are becoming scarce on Earth. Mining these materials could one day make Mars economically viable. Not just a home, but a hub for the next generation of space exploration. There's also a deeper reason: survival. Earth is facing growing threats, from climate change and environmental degradation to overpopulation and dwindling resources. Colonizing Mars offers a potential backup plan, a second home for humanity. It wouldn't be an escape, but a safeguard. A way to ensure that human civilization endures no matter what happens on our home planet. So what's next? For one, the private sector is playing a huge role. Companies like SpaceX are developing reusable rockets like Starship, designed to carry people and cargo to Mars efficiently. Blue Origin and others are investing in deep space infrastructure that could support long-term missions. These companies are moving fast, often faster than government agencies, and their innovation could dramatically accelerate the timeline for Mars colonization. But with that speed comes the need for thoughtful planning. As we reach for Mars, we face ethical questions. Do we have the right to terraform another world? What if there's microbial life on Mars? Do we risk destroying it? Who owns the land, the water, or the resources? And what kind of society do we want to build there? Perhaps the biggest question of all is whether we can become self-sufficient. A Mars colony to truly thrive, it must eventually stand on its own. Growing food, producing water, maintaining technology, surviving without constant resupply from Earth. That goal may be decades away. But every step we take, from robotic missions to manned exploration, brings us closer. In the end, colonizing Mars isn't just about space. It's about human potential. It's about solving complex problems, pushing the boundaries of innovation, and imagining a future beyond Earth. The challenges are enormous, but so are the possibilities. And if we succeed, it won't just be humanity's greatest adventure. It might just be our salvation.